Very good morning to everyone. Welcome to the course on drone systems and control. This particular course is sponsored by MIT on SWAYAN project. The SWAYAN project is about capacity development for unmanned aerial vehicle technology. Under the program, we have 5 different resource centers. Each resource center is focusing on specific area. Here at IISc, we focus on drone applications. Part of that particular program, we will be developing courses, and that courses will be made available for all the students in India to understand about this UAV technology. In that particular program, the first course what we are launching is a drone systems and control. The first lecture we talk about type of drones, basics of drone operations, some history of aeroplane. This is more introductory lecture to understand what are the different types of the drones, how this historically built, and how it's been used for various applications and all this. The instructors are Professor Sureshchandra, which is myself, and my colleague Dr. Rudrashis Majumdar. The technology partner is going to be a MathWork, and the course is completely sponsored by SWAYAN, which is a Government of India initiative from Ministry of Information Technology. This is for capacity development in human resources for UAS technology. So myself and Dr. Majumdar will be teaching this course. We will take you through the entire course, right? And we have TAs, Vignesh Gurumurthy, Neetu and Setupati. These three are the TA for the entire course. What is this course is all about, right? This course objective, we talk about fundamentals of drone, understanding, modeling, simulation of this drone, how do we bring in 6 degree of freedom model, and how we implement this model in MATLAB. And once you understand the model, we'll talk about linearization of this 6 degree of freedom model, how do we develop the control. Once we develop the flight control, basically talking about attitude control system, speed control system, altitude system, auto takeoff and landing. Once we have an understanding of this controller design, we'll talk about how this controller can be ported from the MATLAB to PICSOC. PICSOC is a flight controller where you can port all these softwares. Then we'll talk about navigation guidance for the drones. That's the first part of the module. The second part of the module will just make you to understand, explore beyond what drones can do, understanding the sensor component, estimation algorithm which is required to get the states and so on and so forth. Then finally we come into modeling and simulation in cluttered environment. Here we focus more about autonomy aspect of it, right? Moment you talk about cluttered environment, what we really focusing on, operating these drones in, urban kind of a scenario, or operating these drones in terms of forest regions where obstacles could be present and keep moving. How do we detect obstacles? How do we navigate through obstacles? All those aspects we'll be talking about, right? Finally, the course will just provide students to understand the controller design, and also able to do the simulation of them in the environment, and also we'll just focus on autonomous operations of these drones in cluttered environment. That's a focus of this particular course. At the end of this course, the students will be able to learn the concepts of simulation, control, controller design, and how do we put the controller design into the real hardware, understanding the guidance algorithm and navigation algorithm, so that they can help understand how you can move the drone from one point to another point through global positioning system, or even operating in a cluttered environment, right? And they will also have a detailed analysis and appreciate how these drone controllers works, because there are sensors. You have a primary sensors, you have a secondary sensors. When you have these sensors, how do you use to estimate the remaining state of the drone, and using the estimated values, how do you control and navigate? All this clarity will be there, right? And they will also be able to understand the stability, more importantly, safety. Right? Safety is critical when you're operating the drone, how you can just operate these drones in a safe environment. This course will build foundational understanding of operations and modeling, simulation, control, and navigation such that you can use them in safety, right? And this is the basic, expectation from the students who are taking this course to graduate, right? When they complete this course, we expect them to have these skills, right? Of course, reference materials, books are very important. We have given various resources for the students. For example, we have a small unmanned aircraft theory and complete guides of the drones. These are very important for people to understand about drones and sensors, operations, and so on and so forth. Very important material is on control system engineering, automatic control system, modern control engineering. These courses, these reference books will help you to understand the controller design aspect of it for any dynamical system. Drone being a dynamical system, will understand how we can use these designs to develop expected automatic controllers. From there, we talk about how we make it autonomous, right? Flight stability and automatic control will just give you connections how these controllers are implemented specifically for aerospace systems, right? So first module today, we are just going to give you an introduction to the student about the overview of multi-rotor systems specifically. We'll talk about familiarization of different categories of the drones and their features. And we'll also bring in history of the drones, operations of the drones, how the drones operate to move in a spatial and how they can rotate in a spatial so that they can just go from one point to another point. We'll just give a basic operational aspects of it and try to understand what are the design consideration. If suppose somebody have to design a drone, what are the factors they need to consider? What is the advantage of these drones? What are the limitations of different drones that we can build? Specifically on multi-rotor systems that we are going to address in the first lecture, right? And very important aspect, propulsion system, right? Propulsion system here comprises of the motor, propeller, electronic speed controller as well as the battery, right? Or fuel power means it's a fuel. What is the effect of this propulsion system? How this propulsion system is going to help the drone to navigate in the space, right? Finally, we'll be touching base on safety requirements of the drone. What are the regulations of drones operation in India? Very specific, right? With respect to our country, what are the regulations present? What we need to be aware of if you are operating drones in an urban environment or any specific altitude operations? What are the regulations that you need to understand? What are the safety precautions that you need to take it up, right? Finally, we'll touch base on what are the applications of these drones in real world, okay? But we'll be dividing this particular module into two parts. First, I will highlight on the history and types of drones and operations. The second half of the lecture will talk about the aerodynamic aspect, propulsion aspect, and safety aspects. Okay. Now, coming to overview of drone. Drones are unmanned aerial vehicles or uncrewed aerial vehicles, right? It's commonly referred UAV. UAVs are also called drones here, right? The advantage of these are they are aerial system, they can operate without onboard human pilot, right? Or remotely operated aircraft, you can say. There is a remote pilot. Through radio communication, he can just command the particular UAV or call drone to perform a specific operations. These drones are widely used for surveillance purposes, right? Or inspection purposes, or even in looking at agriculture sector, where precision agriculture being one of the factor which is influencing the productivity and quality of production, right? So identifying pests, where we need to spray, or we can also look at what is the volume of production being present, how much area is being cultivated, or even look at natural disaster kind of an applications where when there is a heavy rainfall or even forest fire being present, how much of the land is being burned due to the fire. So we can look at the biodiversity loss computation, or during the heavy rainfall, waterlogging areas or physical infrastructure loss we can identify and locate it in the map, so that the government agencies can identify which infrastructure got affected, how we can support those infrastructures, right? Replacement or planning, it will be very useful in those scenarios too. In fact, it can be used for survivor detection during the disaster situations, right? But if you look at drone as such, it has various components of interest to us, right? Airframe is basically a physical structure. Typically, this is a structure where you will mount your propulsion system, where you mount the avionics, and this is going to help you to generate necessary lift for your aircraft, right? If you talk about a fixed wing aircraft, later on we'll see what are these types in specific. You have a multi-rotor system, you have a fixed wing system. So this physical structure will provide a rigidity to the aircraft. Propulsion system, that's a very important system. In case of multi-rotor, there is a motor and propeller, which will provide necessary lift and thrust. What is lift, what is thrust, we will see in the next lecture, right? And then you have a power system, right? The power need to be provided for this propulsion system to operate. It could be coming from either battery, or it could be from conventional fuel supply system, right? It could be just engine powered system where you can use conventional kerosene or even petrol or gasoline for engine to operate, and then that will provide power to your propulsion system. Very important is your avionics. Avionics consists of multiple sensors as well as flight controller. The sensor part of avionics, what we are talking of, we have inertial measurement unit. We refer that as an IMU. Inertial measurement units will help the drone to identify their orientation. So whenever we talk about operation without human pilot in picture, you need to understand where am I. Where am I requires the current position. Position can be obtained through global position sensor or positioning information. Where I am oriented, which direction I can get the orientation using IMU sensors. In addition to IMU and global positioning sensor, you have cameras, you have lidars, you have radars. Camera can be used to understand the context where the drone is present, right? A lidar can just help you. For example, you can use a single point lidar as a height sensor, or even single point lidar to find out the distance to a specific point, right? You can also use radar. Radar can also be used as a height sensor. Radar can also be used to detect obstacles in the front, right? Or radar can also be used to find a flat terrain where you can land, right? You can also use camera. We will discuss all these in the later part of the lecture, but just give an understanding. I need a basic IMU, GPS and height sensor minimum required. On top of it, you can add rest of the sensors to make more effective for operation in a specific environment. The very important brain of the drone is the flight controller, right? The flight controller is going to receive inputs from the sensors to understand the state of the drone, and it's going to provide output, the output which goes to the motor to control the speed in such a way that the drone achieve a specific trajectory or as a operate in a safe, stable environment. Okay, the flight controller is a key. It's a brain of the system. Of course, we need a communication, very important, because we are talking about remote control aircraft or autonomous unmanned aerial vehicle system. Right? Moment we talk about autonomy, we are talking about decision making capability. It has to decide what action it has to perform based on the environment in which it is present, right? It also need to communicate to the ground station about its operations, right? It requires a communication system. Basically, we will use a telemetry to transmit the data. Basically, what kind of data? The position, the orientation, and others information like the speed at which I am traveling. If I want to understand more about the environment, I can transmit the camera information also back to ground station. Right? And we can operate them in different modes: manual mode, stabilized mode, and autonomous mode. Manual modes are usually not for the beginners. It's for advanced operators who can just move the drones basically to perform certain maneuver under loss of some informations, right? Probably due to loss of GPS, I can just take it into manual mode and operate and bring it back, right? Stabilized mode is for beginners, right? The aircraft has inherent ability to stabilize and maintain certain orientation, and such that remote operator can just easily drive the drones to what action they want to perform. Autonomous modes are more like a pre-programmed missions, right? We fix the mission. We'll say that take off from here, go to these waypoints and perform the operation and come back, or they have the ability to make a decision and on the way, if they identify an obstacle, they know how to deviate from the obstacles and reach the goal and perform the operations completely. Right? What are the challenges here? The biggest challenge is going to be your wind, weather, and obstacles. Right? Wind is a factor. It will influence the ability of the operation of these drones. Weather is, of course, is important, because if the change in rain or the smoke or fog will limit the sensor ability to understand the situation where the drone is being present. Obstacle is a factor for autonomy. It has to identify whether it is an obstacle. If it's moving, what direction it is moving. Based on that, it has to decide what action it has to perform. Right? Another bigger challenge comes in the sensor inaccuracies. Right? For example, we talk about GPS. If the GPS has a plus or minus 10 meter error, if you're operating inside the building, getting a GPS signal itself will be very difficult. Number one. Number two, the error in positioning will also affect the performance of the drones. Right? Delay in communication to ground station to understand where the drone is, in what scenario it is being present, that will also a factor will affect. Right? The other factor comes into picture is for path planning, for obstacle avoidance. The drone flight controller in real time generate the various paths, safer path for the drone to operate, and so that it can perform the actions expected, or the mission, complete the mission without any problem, right? And of course, the very important challenge is the safety. Safety in operation in urban or highly populated areas, how the drones can operate and how they can maintain the safety of the humans present in the sea. Right? Now, we look at the history of drone, right? History of aeroplanes, I'll just put it, and then I'll start bringing you to the drones level. So 1907, the first aircraft what we have is the gyroplane, for you to understand. And then in 1922, the quadcopter came into picture. It has a 4 propellers, and that propeller which is helping this vehicle to take off. And then 1922, you also have a gyroplane with a single, spinning about its own axis and start operating. Then comes 1907 is also another philosophy of gyroplane. So this is what you need to get an idea about how, we started looking at airborne systems in the early days, right? Now, if I'm going to classify the drones, I will classify based on 2 major categories. Is based on the rotors, right? Number of rotors being present. So what we call multirotors, right? These multirotors are what commonly referred as drones nowadays. It could be quadcopter. We'll look at the various multirotor system later. Multiple rotors are there, will help this particular vehicle to move from one point to another point. Then you have a swash-plate based system, is a typical helicopters, right, which will help you to navigate. Then comes your fixed wing, right? You have a wing, and that will help you to generate your lift, and then you have engines which will generate your thrust, and with that you will be able to navigate. Then we have a hybrid system. The hybrid system has a combination of multiple rotors as well as fixed wing. If you look at the fixed wing aircraft, which requires a runway, right, longer runway, you need to go through the runway to take off, and then it requires a specific infrastructure being present, what we call airports, right? We need those airports and runways for them to operate, okay? But if you look at the multirotor, it doesn't require any runway, it just needs it from a point. It can vertically take off from that particular point and start navigating, right, from anywhere. Right? Helicopters also can just take off from the ground vertically and then they can navigate. We generally refer them as vertical takeoff and landing capability. Whereas if you look at aeroplanes, they have horizontal takeoff, okay? They have to take off using a runway and landing, right? Hybrid systems, they have the advantage of fixed wing aircraft, because with fixed wing aircrafts can operate at high speed, right? Whereas we look at the drones or helicopters, operation speed is limited. And the advantage of these are they can take off vertically and land vertically. So hybrid will have advantage of both fixed wing as well as multi-rotor systems. They can take off vertically, they can land vertically. In case the propellers have some issues, they can also use infrastructure like a runway to land. What we meant here, drones, is a broader term used nowadays to represent unmanned aircraft, particularly multi-rotor systems. Right? Now, this particular course is going to focus more about multi-rotor operations. So, we'll look at what are the different types of multi-rotors we have, right? How, based on how they operate to get the lift and how they can control, what are the propulsion system present, we can classify them, right? And they are very popular because of simplicity in construction and ability to hover is stay at one particular point, right? And they are useful for many civil and military operations. For example, if you want to inspect a tall building, a tall structure, you want to look at any crack, or you want to operate for firefighting, and these drones are going to be really useful for inspection, surveillance, and those kind of applications, right? Now, we can classify these rotors into different types based on number of rotors present. If you have 4 rotors, it is called quadcopter. It's the most commonly used drones, right? 6 rotors, right? More lift, more redundancy. Even if one motor fails or one propulsion system fails, out of 6, it can still provide reliable mission, right? Then 8 rotors is highly reliable. Reliability comes with the cost. Highly reliable, less maneuverable, right? So you need to understand that size will increase, right? You can increase the payload capacity, but then you have to compromise on maneuverability. Tricopters, on the other hand, if you look at, which has 3 rotors, moment you bring lesser number of rotor, maneuverability comes into picture, but it also comes with a compromise on stability aspect of it, right? How do you achieve the control in getting certain orientation is going to be really challenging, okay? Not just the number of rotor, it is also depends on configurations, right? How the motors are going to present, you can have a coaxial, or you can have stacked rotors to increase the power to get a compact size, right? So what we have is a quadcopter. What I mentioned, basically you have a 4 rotor, hexacopter, you have 6 rotors, right? You have octocopters, we have 8 rotor system, right? Tricopter, 3 rotor system. See here, achieving the stability and orientation is going to be challenging. Then X8 configuration, basically we are the motors and propellers are mounted in the X configuration. right? So you can also have plus configuration. You can mount the rotor propeller in the plus configuration also, right? These things will affect. You see here we have two propellers stacked on the one on the top, one on the bottom. This is what we call as a coaxial design, which is different from the quadcopter what you are seeing here, right? So this will reduce the size, increase the ability to, compact size so that you can just operate with the same payload capability, right? Now, what is the advantage and limitation of these drones? Now, control mechanism, right? Thrust variations is possible by varying the speed of this particular motor. If I can change the speed, I can change the thrust that I can produce from this motor, and using the thrust variations, I can get roll, pitch, yaw, right? Roll is about x-axis, how do you rotate? We'll talk about the drone operations a little later. You can pitch, which is like basically moving forward and backward, right? Yeah, it is about spinning about the z-axis, and you can vary the height of the drones also. That's what we call altitude, right? By controlling the thrust produced by individual motor propeller system, I can control the drones in all three axes, rotation in all three axes, and also control the height of operations, right? Of course, you have the brain of the drone, which is the flight controller. Using the flight controller, we can process all the sensor data, IMU, GPS, LiDAR, all the data we can process, and we can determine what is the appropriate speed command to be provided in such that we can just control the thrust, right, and also torque generated by each motors, right? So by controlling this, we can control the orientation of the drone and its position, right? Whatever consideration we take, we talk about design of a particular drone, number of rotors. Why this is important? If you are going to operate a drone in a cluttered environment where the space available for movement is constrained, then you need a highly maneuverable drone. If you increase the number of rotor, you have more stability against failure, but at the cost comes with the increase in size and less maneuverability. It's like a bicycle versus a four-wheeler, right? So we have to take the consideration of how many motor propeller system we are going to have, right? That, and also propeller size, right? When I talk about what is a propeller twist, what is the length of the propeller, all going to affect the thrust generation capability, right? Materials too, right? So materials will talk about if they stiffer, they won't flex, they don't flex, which means they can get a high reliable thrust generation capability. Very important aspect comes in motor selection. You need to balance the power, weight, and efficiency, right? That particular motor should be capable of driving this particular propeller to a specific speed so that we can just get the maximum thrust that we can generate, right? Of course, all these require power. Power can be provided either from a battery or from conventional fuel system. We are talking about battery powered systems. Okay, so it determines the duration, it determines a weight trade-off, right? So you have to fly longer, you need to have more power. More power means more batteries. Batteries will increase the weight, and we need to take all these aspects into it when we are designing the aircraft. What is the advantage? Of course, we know this is what we've been talking about, vertical takeoff and landing. So you don't really need a runway. The moment you don't really need a runway, you can take off from any flat terrain and land in any flat terrain. Remember, flat terrain is needed, right? Hovering capacity, capability. It's ideal, right? So if you have a propellers, I can stay at one particular height. If I can stay at one particular height, I can take pictures very effectively, right? Motion pictures is possible, right? I can inspect any tall structure. right? I can inspect remote locations because I can go to that particular point, stay longer, even if I have to use ultrasound sensors to look at the health of the structure, I can do it because I can hover at that particular height. The very important aspect why drones are gaining popularity, ease of control. Right? You can achieve the stable flight due to the simple dynamics. You can, you can build the drones, you can control them very easily. Their agility makes a difference, right? We can have a very high speed, highly maneuverable system. They can just provide agility. They can spin, or they can just vertically go upside down and come back to its normal position. That agility makes them very interesting to operate in a cluttered environment, right? And the precision, capability to position it at one particular point is also a factor influencing use of the drones for various applications. But it comes with the limitations, right? The limitation is shorter flight time. Because we are using motor and propeller, flight time is affected by capacity to carry your battery, right? And also comes with the payload constraints. If you want to carry heavier payload, they will introduce wind-related drag, and that will affect the ability to carry heavier weight because the wind variations do influence the performance of the aircraft, and also the range to which we can carry the heavier payload. That's a factor that I was mentioning, sensitivity, right? The gusty wind comes into picture. The variations in thrust across the four motors going to be different. That leads to operational inefficiencies, right? Of course, efficiency, right? Fixed wing aircraft has the ability to generate a lift because of the wing being present, and that wing is helping you to achieve the high speed operations too, right? Here the lift is produced by the thrust which is coming from the motor, right? And these motors orientation, the speed at which we are just rotating will also help them to navigate in the space. Their efficiency is also a factor, right? We look at the motor, propeller, as well as the battery combined together, the speed controller which comes into picture to control the speed at which the motor is going to spin, all that affects the overall performance of the aircraft. Now, we talked about other type of system, which is the helicopter, which works on the philosophy of Swash-plate based system. Primarily, these are also called rotary wing aircraft, right? They use the squash plate to orient the thrust direction so that they can maneuver in the XY plane. Right? What is this swash plate? It's a mechanical interface between the stationary frame, that is the body of the helicopter, and the rotating frame, that's the blade that we are talking of. This is what we are referring to swash plate, right? This particular element is a swash plate. So what it does is, by controlling this plate, I can control the pitch of the propeller, or I can control the by controlling the pitch of the propeller, I can change the thrust that I can produce, and I can control the speed of the motor also to produce a thrust. Okay, so I can change the thrust direction using the squash plate, and then I can maneuver this aircraft. Purpose of these type of UAV, which is basically helicopters, they have a collective pitch control. They uniformly change the pitch across all the blades, which can help you to achieve the altitude control system, basically varies the height of your system. And you have a cyclic pitch control. By changing the pitch of the individual blades, you can control pitch, roll, and yaw motion. This is your pitch motion, right? And roll motions, you can control them. And this helps you, this squash plate, combining the collective and cyclic, gives you the high maneuverability and also gives you the hover-like multi-rotor system, right? Of course, they are dynamically maneuverable, very efficient in hovering like a multi-rotor system. They are useful for heavy lift because these are mostly engine powered. I can carry more fuel and then I can operate. The challenge again comes into mechanical complexity because you have the swash plate controlling them. Their vibration will just transmit. That leads to complex mechanical design, right? Of course, the weight, cost, vibration is the biggest factor here, which we need to take care of it. Then comes fixed wing UAVs, right? They can operate very high speed. That's what I mentioned. They are useful for long range, high speed, right, operations. They are more efficient in terms of energy when compared to multi-rotor systems, right? They rely on lift, which is produced by the wing, right? And the airflow which flow over the wing, which will help you to generate the lift. And you have a fuselage where your payload basically present and the propulsion power system all present in the fuselage. And then you have control surfaces, right? The control surface present here as well as here, right? Which is basically help you to orient your aircraft in a different angle. For example, the ailerons will just help to control the roll, the elevator helps to control the pitch of the aircraft, the rudder helps you to control the yaw of the aircraft. Propulsion system, typically it could be motor driven, right, or engine driven. I would put it best, engine driven, right, and they could be electric, or they could be fuel, or they could be hybrid powers, depends on on the application that we are looking at. They have a landing mechanism at the bottom, which is retractable so that they can reduce the drag when in the high speed motions, right? Advantage as mentioned earlier, they are very good for long flight durations, right? They are energy efficient when compared to the multi-rotor. They are suitable for high speed operations. They have the capability to glide. The one disadvantage is they can't hover, but they can just go glide around a particular point, right? So they cannot take off vertically and landing, which means they need a runways to launch, or you could use a catapult launch. High power catapult launch is possible. They don't have the hovering ability. Operational complexity comes into picture, and you need a highly skilled operator when you wanted to look at them, because it's operating high speed, right? The skills required to control these drones in remote is really challenging. Okay. Now, hybrid systems. Hybrid systems has the ability to take off vertically, land vertically, and they can also operate at high speed, right? There are various types of hybrid systems are possible. Tilt rotor. The rotor itself can tilt, right? During vertical takeoff, they act like a multi-rotor, and this rotor tilts forward to provide the thrust required when you want to move from vertical to horizontal operation. The transition from vertical to horizontal is challenging in all these hybrid systems, right? You could have quad plane kind of a structure where you have a pusher, separate pusher for the thrust, and you have a multi-rotors are present on all, four multi-rotors are there, which will provide the vertical thrust on what you need. So using combination of this, you can control this aircraft also. And another one is you can have a powered lift, right, the high speed, and you can also think of a tail seater. They can land vertically down, and it can do the translational flight, right? But all these hybrid aircraft has its own operational challenges and limitations. They have a flexibility like a multi-rotor system. They have efficiency for a long durance operations. They have maneuverability. They have high payload capacity. These are the advantage. But when it comes to limitations, if you see, the complexity comes into picture. They have both the mechanism which leads to complexity, particularly the transition flight from vertical takeoff to horizontal translation. That's going to be really challenging to control, right? Weight of the aircraft, the trade-off in efficiency will also comes into picture. Up to what point you wanted to have the vertical takeoff capability and then transition flight. So this is an interesting aspect that one need to look at it when you are designing the hybrid multi-rotor system, right? And that's all for today. So we talked about what is drone, what are type of drones, and how these drones are classified based on the types of multi-rotors and wings. And in the next class, we will be discussing more about drone operations and aerodynamic aspects of it, safety and regulation aspects of it. Thank you so much.